Lab 26, example 1. We want to identify the degree, the leading coefficient, the zeros with multiplicities, and sketch the function. We have y equals x minus 5 times x plus 2 times x minus 6. So the first thing we're going to do is identify the degree. The degree of a function is essentially your biggest x, or the largest exponent of what it is of your x. So if we multiplied this all out, then we would have, our first term would be x times x times x. We would have x to the third. So because of that, our biggest exponent that we'd have for our term x would be 3. Or you could just count the zeros. We have 3 zeros. We have 1 0 at 5, 1 0 at negative 2, and 1 0 at positive 6. We have 3 zeros, so we know that degree is going to be 3 as well. So our degree, and normally we use the degree and we use the term n to show what a degree is. N is 3, so that's our degree. Our leading coefficient is going to be the number in front of our biggest x, the x with the largest exponent. So again, if we multiplied this first term, we would have x times x times x. There would be a 1 in front of that x to the third power. So our leading coefficient is going to be 1, and I'm going to use a to show the leading coefficient. A is equal to 1. So this is the leading coefficient. Okay, so the zeros with multiplicities. So we have 3 different zeros. So if we set y is equal to 0, I'm just going to show this. If we set y is equal to 0, then we have x minus 5 times x plus 2 times x minus 6 is equal to 0. And this will equal to 0 if any of these zeros are 0, correct? So we can simply just set this is equal to 0, figure out what it is, set what this is equal to 0, and set this equal to 0. And if either of those are true, then the whole function will be 0. So if x minus 5 is equal to 0, then we have x is equal to positive 5. If x plus 2 is equal to 0, then we have x is equal to negative 2. And if x minus 6 is equal to 0, then we have x is equal to positive 6. So these are our zeros, and we want to figure out what the multiplicities of them are. Well, the multiplicities is just going to be how many times we have that 0. And here we have the 0 once, and we have this 0 once, and we have this 0 once. If there was a 2 here, then the multiplicity would be 2 for 6. If there was a 3 here, then multiplicity would be 3 for negative 2, and so on and so forth. However, they're just multiplied one time, so the multiplicity for all of these zeros is just 1 for all. So, moving on, we want to sketch the function. So I'm going to draw a little graph here. So, and then we have 3 different zeros. I'm going to mark them on the graph. We have 1 at negative 2, and we have 1 at 5, and 6. And now that we know that, we're going to go back to what we know. So we know the multiplicity is 1, which means it's going to pass through each of the zeros. It's going to pass through the x-axis. It's not going to bounce off. And we know that a is 1. Now, if a is greater than 0, and it has an odd degree, which we do have an odd degree, our degree is 3, then we know that the graph is going to be down on the left and up on the right. So it's going to be coming from down on the left, and it's going to go up on the right. So that means that it's down from here to negative 2, and it's going to pass the y-axis somewhere. It's going to come down to 5. Again, it's going to pass through all of these zeros because each zero has multiplicity 1, which is odd. And then it's going to come up through 6, and it's going to go up on the right. So that's all the information we have. We don't really know where this y-intercept is, but here's the a little sketch of what it probably will look like, and the answers to the rest of the questions.